Hello everybody, this is a video lecture for 1314. We're doing 1.2 linear equations and irrational equations. So anyways, we're going to be solving for x. That's what they're trying to say here, right? Solve for x. And let me prove it to you, blah, blah, blah stuff there. Solve for x, solve for x, solve for x. I think that this makes me feel at home because we often have been brought up and raised to do this sort of thing, and it's just a key feature of algebra classes is to solve for x. Here we are, we're doing it. I have Desmos graphing up here now as well because I do want to show you a little bit of both as we go through this, okay? So Desmos Scientific from last time, that's great. It's cool. I'm going to have it around, but Desmos graphing, it's going to be our ticket here, okay? So I want to do I want to do it. I mean, you can read all this stuff all you like, have fun with that, but I'm just going to do it because most of us probably already know what to do, but I want to do it with you. So here we go. Solve for x. Every time, solve for x. So what do? I'm going to move all my numbers over here and leave my x alone. And so first off, I'm going to add 4 to both sides. And so those guys cancel. And now we have a 12. And I say, oh, divide by 3 on both sides. Whoop. And 12 divided by 3 is 4, and we're done. So that's pretty cool. And we're going to continue to do that all the way down. But, I mean, this is a simple problem. It's very simple. And it's a perfect opportunity for me to show you the power of Desmos graphing. This class, Math Algebra 1314, you can use Desmos graphing on all of the exams, at least at the time of this recording. And so I will be doing all this stuff by hand, but I want to show a little bit of Desmos graphing as we go through it too. How can I make this thing work for me? 3x minus 4 equals 8. I just type in whatever they got. And almost always, at least at this point of the game, there's a line, you click on it, and it tells you the answer, you're done. That was it. There you go. Wasn't that easy? I want to show that to you right now with this next one right now. And so 9x minus 5x minus 13 equals 41. And there it is. It's 7. You're done. It says, what's x? It's 7. You're done. Next question, right? Well, no. We need to do some of this by hand right now so that when there are problems which don't work so well here in Desmos graphing, I'm prepared for them. So I have to learn math. A math class. Go figure, right? So again, some of these are easy. I'm not going to shy away from Desmos. But I do want to do both. I'm going to do this by hand as well. So here we go. To simplify, I would personally start with distributing the minus sign. And so then I got a negative 5x, and then 2 negatives make a positive 13. Combine like terms. See, all of this sounds very familiar, as if we've done this before. As in, like, the last sections. Yeah. Minus 13 on both sides. 41 minus 13. Another thing with Desmos graphing, although it's not recommended, you could just get, like, numbers. That's fine. It would be much easier, of course, to go to scientific. So 41 minus 13. See, it's clear, it's easier, it's beautiful. So here we go. And then, of course, divide by 4 on both sides. And, oh my gosh, guess what I got? I got 7. Cool, huh? Okay. So I know you can fast forward to the end. No, we got to do some of this by hand now so that when we get to the difficult questions that can't use it, then you're ready. So here we go, the next one. I need to get all my x's on one side and numbers on the other side. I recommend moving the 7x over here so that I got 8 minus 7 is just a 1x, which you can just write x. Add the 4 on both sides. You got a 9. See, that wasn't hard. Psst, that wasn't hard. Come on. Psst. Sound effects included. Oh my gosh, that's hard. No, Chad, I can't do it. No. Desmos will do this one too. Now, I think that it's like going to run past where you could see everything, but Nevertheless, there's your answer. Wow, that's so cool. Okay. Um, oh no. It's not giving me that little thing again. Hold on. Scribble, scribble. Scribble, scribble. Come on. Okay, click on, off. Ah, we got it to work. Okay, good. I'm still going to do this by hand. Distribute. 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 4x minus 20 minus 5x. Two negatives make a positive 20. Leave that alone. Minus x plus 3. I got to say, this one's pretty cool. Do you see something here? Yeah, exactly. You can cancel all those guys out. And so we're left with, on this side, 4x minus 5x is a negative 1x, just negative x. And then on this side, we got a 7. A lot of people say divide by -1 or divide by a negative or whatever. You can just switch the signs. It's up to you. You do whatever you want to do at this point. There it is. We're good. All right. Now for that one. Man, it's fractions now, Chad. There's no way that Desmos graphing can do this one. No way. I mean, it's fractions, right? I mean, come on. There's no way Desmos graphing fractions. Look! It won't work in Desmos graphing. Yeah, you zoom out, actually. And there it is. There's your answer. Oh, man. I know it's a big number, right? So, that's the thing. You got to be able to know Desmos graphing. If you didn't zoom out and you're like, oh, there's no solution. There is a solution. You have to look for it, okay? So how do you do this problem with fractions? And I got to say, a lot of people say common denominator. Yeah, kinda. That's a long way. I'm going to do some bad math. Yeah, I'm doing bad math. And I'm just like going to tell you that. What I'm going to do is I'm going to say the whole darn thing times 72. Now, pause for a second. Why did I choose 72? Where did the 72 come from? It's right here. 8 and 9 makes a 72. But I want that 72 for every single term. It looks like bad math. It kind of is. Bad notation, at least. So 72x over 8, and then equals 72x over the 9, and then 6 times 72. So I know there's a lot going on here, but consider each point. What is 72 divided by 8? Oh, yeah, it's 9. Hey, what's 72 divided by 9? It's 8. And then what's 6 times 72? I don't know. Oh, look at that. We've seen that one before. Oh, my goodness. And so I'm going to minus the 8x on both sides. Whoop. So we got 1x, just x, is equal to this ginormous number. There you go. Sweet. Isn't math fun? Come on, man. I'm making it fun, right? That's the point here. Well, the point's for you to learn, but I'm making it fun. Let's do another one. What am I going to multiply the whole thing by? If I'm doing bad math. Come on, bad math. It's times 60, right? 12 times 5 is 60. I'm choosing that because what's going to happen is everything cancels out in the end. So we have a 60, then I have a 60, and then I have a 23. Okay, so what's going to happen is these guys here and these guys here are going to cancel out a little bit. So that's going to be now a 5. And this one's going to be a 12. Sweet. 7 times 5 is 35. Minus 12x on both sides. 13. Am I doing that right? 23, 13, 23, 23. Watch to the end. Watch to the end. I was like, something's not looking exactly right. Okay, cancel, and we got x is equal to 1. Okay, let's verify. Verify, especially now that I'm confused. Oh, man, Chad's confused. You don't know what's going on. Again, my name's Chad. Hello. So, here we go. Yeah, I definitely did something wrong. Oh, I see it. I see it. Oh, watch to the end. And this is exactly why. This is exactly why we watch to the end. And why we have Desmos to help us out once in a while. I said everybody gets a 60. You get a 60. You get a 60. You get a 60. Ah! I forgot that. Do I make mistakes? Yes. Yes, I do. And that is okay. I will admit it. Even when I'm doing my own little tricks, I still make a mistake. I would say that this trick is still a good trick. Okay? It's bad math, but it's not really bad. Okay? It's not really bad. It's just that I forgot. And it happens. Okay? So let's do that math. So 1380 divided by 23. Aha! Is 60. There you go. So yeah, I did make a mistake simply because I just didn't give everybody a 60. There you go. I don't give 60s. I give 70s, right? That's what I do around here. You're going to pass the class. Yeah. No, I'm just playing with you. Oh, man. Just having fun with you. Okay. Example. Oh, word problems. Gotta love it here. And we got, then we got the end. That's it. This is when we got the one left over here. So, blah, 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 blah. We got a formula, and it says X is years after 1970, and they're talking about 2010. So we're going from 1970 to 2010. So my X is equal to 40. Very good. And so what I'm going to do is plug in X equals 40. So I got P plus 40 over 2 is equal to 31. So that's a 20. Minus 20. So P is equal to 11. Yay, we got it. But now, here's the thing with this one. It's not really supposed to be 11. We're comparing it with the 2010 actual answer. So I can't say it's 11. I said that I got an 11, but they got a 10. And so mine, it says model. Mine is over by how much? Well, 11 minus 10 is 1. 1%. That's what they're really wanting for that. So watch out, okay? Watch out. This one here, notice that it's a little backwards. It says we have a percentage, go and find out the year. So as in like I have P plus X over 2 is equal to 31. So that P is right here now, 15. X over 2 is equal to 31. Minus the 15 on both sides. So X over 2 is equal to 16. And then I have to multiply by 2 on both sides. So 32. 32, that's my answer. Haha, 32 AD, right? No. It says in what year, and we started in 1970. And so you got to use some math. Aha. 2002 AD. They don't have AD in my math lab, but I'm telling you, that's what they're saying. What year? We're talking like the year, not how many years. Okay, so the year. Okay, cool. And that was it for that whole section. Look at that. So there you go. Thank you very much, and have a great day.